In this example, we'll be finding the square root of 111 by approximating it to the nearest tenth place decimal. To do this, we'll look at perfect squares near 111. 10 squared is equal to 100, while 11 squared is equal to 121. We can see that 111 falls between 100 and 121. We can therefore write the following inequality. 100 is less than 111, which is less than 121. Now we can take the square root of all of these values. The square root of 100 simplifies to 10, as 10 squared is equal to 100. The square root of 121 simplifies to 11, as 11 squared is 121. Now we have the following inequality. 10 is less than the square root of 111, which is less than 11. This means that the square root of 111 lies between 10 and 11. To find a tenth place approximation, we want to look for a tenth place decimal between 10 and 11 that, when squared, gives us about 111. Because 111 is pretty evenly distributed between 10 or 100 and 121, we can try something between 10 and 11, or 10.5 squared. So let's see what 10.5 squared is and see how close that gets us to 111. 5 times 5 is 25, carry the 2. 0 times 5 is 0, plus 2 is 2, and then 1 times 5 is 5. Add zeros in for the next row since we're multiplying by 0, and then the last row needs 2 zeros, and then we'll multiply our 1. 1 times 5 is 5, 1 times 0 is 0, and then 1 times 1 is 1. Adding these values together gives us 110.25. This is very close to 111, and we can actually approximate it to about 111. This means that we can write 10.5 squared as approximately 111. Taking the square root of both sides will cancel the squared and the square root on the 10.5, and we're left with 10.5 is approximately the square root of 111.